Hello everybody, so in this video we're going to be dealing with segments inside the circle. So we're going to be looking at what's going on with all these relationships with chords. If you remember, a chord is a segment whose endpoints are on the circle. Okay, so first off, in the same circle or in congruent circles, minor arcs are congruent if and only if their corresponding chords are congruent. So what that means in this picture here, you see that chord AB is congruent to chord CD, which means that the arcs that they capture, arc AB, is going to be congruent to arc CD. Okay? So if we've got a situation like this, where we have congruent circles, both FE and CB are congruent, so this arc of 125 degrees is going to be repeated over here for arc BC. All right, so that's our first relationship. Next up, what happens when a chord and a diameter is a special type of chord that goes through the center, what happens when they meet? So if we have a chord that is if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So this diameter is coming through here and it's cutting this chord in half. All right, so I know SQ has to be a diameter. Okay? That's the only time that situation is going to happen. So the converse of that, or the flip-flop, basically says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So we got a little extra information there. All right, so it also bisects this arc. So it cuts arc TR in half. So TQ, arc TQ, is going to be congruent to arc QR. All right, next relationship deals with congruent chords. So in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. All right, now the segment that goes from the center and touches that chord isn't a radius because it doesn't touch the circle. All right, but for example, here we've got that CL and CM are congruent. So the circle is centered at C, and it extends out and hits the chords, and those segments are congruent, meaning that these chords, XW and YZ, have to be congruent. Okay, so in this example here, we've got that AB is congruent to DC. We've got that those two chords are congruent. Therefore, these segments that extend from the center have to be congruent as well. So we can set up 3x equals 7x minus 8. All right, so we got negative 4x equals negative 8, so x equals 2. Alrighty, so those are three relationships. Real quick. All right, so those are some relationships with chords. The next one, though, is really what a lot of your problems on quizzes or tests are going to be. All right, and what's the relationship when we have two chords that intersect inside the circle? Okay, so if two chords intersect, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segment of the other chord. All right, so this one is part times part equals part times part. So QB times BR equals SB times BT. So the big relationship here is part times part equals part times part. This is the big one for this section here. When I'm dealing with chords intersecting inside the circle, so the segments are contained inside the circle, part times part equals part times part. So like with this example here, we've got part times part, so 5 times 12 equals part times part, 6 times x. So we get 60 equals 6x, so x equals 10. All right? So put that on a note card, part times part equals part times part, for when you're dealing with segments intersecting inside the circle, when you're dealing with chords. All right? So a lot of relationships here with chords. So make sure you get those on a note card, you study those relationships, you understand how they work. You've got 4 you try now problems here for you. Okay, really good practice. Make sure to complete those before the next time I see you. If you have any questions, bring those to class. Other than that, be safe, be good. I'll see you when I see you.